All right, so this is video number 3. Obviously, for people in class, it's your first one seeing it. But during third period, I did 1, 4, and 7. ... During fourth period, I did 2, 5, and 8, etc. And now this is sixth period. I'll do 3, 6, 9. And the videos are, I think, nicely labeled in the folder, so you can know which one you're getting yourself into if you're looking for something. Number 3. The polynomial function f is given by this thing. Which of the following is true about f of x over x plus 3? Okay, the remainder is 0 or the remainder is not 0, and then go from there. So I guess let's divide and see what we learn. And a synthetic divide with -3. Bring down the 2. Multiply, add. Multiply, add. Multiply, add. Hey, you got a remainder of 0. That's kind of nice. So the remainder is 0. So it's either A or B. I can throw C and D out. Okay, the rest of this says the quotient is a quadratic polynomial that factors into two linear factors, or the quotient is a quadratic polynomial that does not factor.
It doesn't factor because one ends on note 6.
So I got remainder 0. I just need to know if the leftover part, the answer, the quotient, 2x squared minus 9x plus 4, basically if that factors or not. So let's see. I'm thinking 2 times 4 is 8, so I'm thinking there's maybe a way to do this. Put the 4 across from the 2, that gets me 8. If both signs are negative, -1 and -8 make -9. -1 times -4 makes 4. So yes, it does factor. So my answer choice is A. Number 6. For the polynomial function g, limit as x goes to -infinity of g of x equals -infinity. Okay, well, job 1 on these, I feel like, is to translate that from math back into English, right? Like from technical notation stuff into what is going on here. Well, as x goes to -infinity, which end is that? Is that left end or right end? That's the left end. So left end. And if the function is headed toward -infinity, that means the left end is down. So I've translated this from math speak into normal understanding things. The left end is going down. So I need to figure out which one of these has a left end down. The trick about left end is that you can't tell what the left end is doing directly, right? You only know the left end relative to the right end because it's based on the degree, and the degree tells you if it's the same or opposite. So it's kind of a complicated question because I don't know what the left end does until I know what the right end does. So let's just go through and see. Part A, or answer choice A, the right end would be down because of the lead coefficient. Right end is down because of that. What about the left end? If it's to the fourth, my first conclusion is that means it's the same, which in this case is down. So even means same, odd means opposite in terms of end behavior. So I think we got it right there. That's the one. Let's keep going though in case I messed that up. You also see that all of these are out of order just to jack with you a little bit. Like you got to look at the lead term even if it's not in the first position. So this one would be right end down because of the negative lead coefficient. Left end would be the opposite because of the odd. So that would mean left end is up. So B's out. choice C. Negative means right end is down. Odd means the left end is opposite, which would mean up, which is not what we want. And then lastly, the right end is up on that last one because the lead coefficient is positive. But the degree is even, so the left end is doing the same, which means up, and that's not what we wanted. So yes, it was A. So again, the trick with the left end is you can't tell directly what the left end does. You can only say the left end does the same or the opposite as the right end. Number 9. The figure shown in the graph is the graph of a polynomial. Which of the following could be an expression for g of x? Okay, so let's see. First thing I notice is what's going on right there. That's a double root. It could be any even. That's fair. That's fair. It could be a fourth or a sixth or an eighth. That's right. Of course, I look at my answer choices and I don't see anything like that. I do see a couple of doubles. So already I'm looking at C and D. And if that's x equals, the difference is minus 5 or plus 5. Well, if that's a double root at x equals 5, then what factor would lead to x equals 5? Yeah, that means x minus 5 was the factor. So it's got to be C. So the double root and the plus minus thing on that one. Number 12, what is the degree? So this is where we do those common differences and just keep doing them until they match. So a first difference, and remember we can maybe try to cheat the system and start with the easy numbers and see if we get there without having to deal with 389. So from 35 to 5, that's down 30, negative 30. From 5 to 1, that's negative 4. 1 to negative 1 is negative 2. Negative 1 to negative 1 is 0. Negative 1 to 25 is 26. So that's my first difference. So it's not linear. I mean, I knew that already, but second difference, from negative 30 to negative 4, that's going up 26. From negative 4 to negative 2, that's going up 2. From negative 2 to 0, that's going up 2. And from 0 to 26, that's going up 26. This is a little bit dangerous. If I had only done that much of it, and I'd say, 2 equals 2, I found it. Like, better look a little bit more carefully here. Well, the third differences aren't going to be the same either. That is 24. That's 0. Oh, that's negative 24. That's 24. Fourth difference is looking good. So that's up 24, and that's up 24. Now, I suppose I should be extra careful to make sure that this didn't happen. Right? If you only got 2 that are equal, you could be being misled. Let's go one more over here. This shouldn't be too bad. That's 100. That's 74. That's 48. Okay, now I feel fine that that's a fourth degree. I mean, I can't imagine you'd have all 3 be equal and then they start doing weird things over on the other side. Number 15. A function q is a polynomial of degree 3 if q of 5 equals 0. I don't know that a picture is necessary, but it kind of helps me think about this. Which of the following must be true? Okay, so degree 3, so I'm thinking cubic, something like that. Q of negative 5 equals 0. I don't know, maybe, but I don't think that's definitely not a must be true. Q has 2 complex zeros. Yeah, maybe if it does the wiggle thing like that. But I don't know that that's a must be true situation. Q can be expressed as x minus 5 times p of x, where p is a polynomial of degree 2. Okay, I think we're on to something here, because if x equals 5 is a root, then x minus 5 is a factor. And if this whole thing is a cubic, then the other factor's got to be a quadratic. Right? We don't usually say things like a linear times a quadratic is a cubic, but that's a true statement. So C looks good. D, Q can be expressed as P divided by x minus 5, where P is a polynomial of degree 4. I feel like that's a maybe. I don't like that one. I definitely think C is right. D, that's sort of backwards. Because x minus 5 is a factor of Q, not a factor of P. I mean, not necessarily a factor of P. Number 18. The graph of the polynomial is shown. Which of the following could define P of x? Oh, this is similar to the one we did earlier. This is like very similar to the one we just did a minute ago. I got a double root at x equals 4. So x minus 4 squared, maybe to the 4th or 6th, but I look at my choices and squared's the only thing going on there. So x minus 4 squared is that one, and that's the only one. So that one, just that one root, settles it. The other one, I guess, just to make sure, is x plus 3, but it's a single root because it crosses through. So yeah, it's answer choice B. Right? Again, if you want to find all the other solutions, they're on one of the other 2 videos.